core sampling has been the way road builders and bridge engineers determine the subsurface soils on a planned project. However, the information is not complete, and the core samples often miss a drastic change in soil conditions between the samples. The misdiagnosis can be costly. So researchers with the University of Texas at Arlington have investigated a new technique called electrical resistivity imaging to help fill in the gaps.
TxDOT faces many cost overruns and change orders. And many of these cost overruns and change orders of the project are due to lack of sufficient subsurface information.
For any infrastructure project, a road or a bridge, before we can design it, we have to figure out what's going on with the ground underneath it. And traditionally, we would drill. We would get borings where we drill down, either run tests in situ, or sample the soil, take it back to the lab and measure engineering properties. It's fairly expensive. There's only so many borings you can do for any given job site.
And it's kind of a hit and miss approach. And so we may be missing a very critical element of what's underneath. And if we have missed it during our investigation, we definitely have to pay for that during the building of our infrastructure, or we have to pay, we're basically deferring that to when that structure fails.
This research project enables TxDOT to do more with a geophysical method called electrical resistivity imaging.
What you get from these technologies is a bunch of numbers and images, which is telling you what the electrical resistivity in the ground is. But it doesn't relate that information to soil. So what we did is we basically visited 5 districts. We collected soil samples, and those soil samples, we brought all of them to our labs. In our lab, we did lots of testing, electrical resistivity testing, and many of the geotechnical, basically, testing. Then, using this information, we created a manual, and in that manual, we explained that how electrical resistivity should be done, and we included equations and charts that they are establishing relationships between electrical resistivity results and geotechnical parameters that we use in our designs. We also included information of how to interpret electrical resistivity images.
During our planning phase, we have to go through our environmental process and schematic development. That includes alternative analysis for at least 2 or 3 alternatives. And this technology will give us preliminary information on what's underneath, under the footprint of each alternative. In that way, we'll be able to decide if some of alternatives are better than the others.
We're basically bringing subsurface site investigations into the 21st century. We're very good at leveraging the traditional methods of site exploration, but now we're leveraging more advanced methods.
For more information and to find the publications for this project, please visit the TxDOT Research Library at the link shown below.